where that nu belongs to any positive real number. So I can write r plus union 0. Means nu is a positive real number and maybe 0. R plus means set of all positive real numbers. Now I have shown that what is the solution procedure. Basically, to solve it, we need Frobenius method. So by applying Frobenius method, uh, the initial equation. So we are applying Frobenius method. Then we got what initial equation. What is the initial equation? R square minus nu square is equal to 0. So which implies R, it is either plus mu or minus nu. Now for means I have shown one solution for R is equal to plus nu. So R is equal to plus nu, we are denoting it the solution as y1x, right? So we will get a solution for R is equal to nu. I'm not writing exactly what is y1. It will be a series which is means which is of the form x to the power nu into what, that even degree terms only. And on some modification we will get jnx, j simply j nu x actually. In general it is called j nu x. Okay, and that j nu x, it is called what, it is called Bessel's function. Do you remember up to that I told?
Yes, sir.
What is the form? Do you remember? It is m 0 to infinity minus 1 to the power m x to the power 2m plus nu divided by 2 to the power 2m plus nu m factorial, and it is gamma of nu plus m plus 1. Okay, so we cannot write it as nu plus m factorial. Look, normally what is the formula for gamma? Gamma of some k plus 1. If k is any integer, we can write it as factorial k, or gamma of k is equal to k minus 1 factorial. Is not it?
Yes, sir.
But can we write gamma of nu plus m plus 1? It is equals to nu plus m factorial. Answer is no. Answer is no. Why? Means we don't know what is the value of nu. If nu is any fraction, in that case gamma of some fraction, we cannot write it in factorial notation, right?
Okay, sir.
If nu is integer, then we can write it as means nu plus m factorial. So it is the general formula for Bessel function j nu x. It is equals to summation m0 to infinity minus 1 to the power m x to the power 2m plus nu divided by 2 to the power 2m plus nu m factorial into gamma nu plus m plus 1 factorial. Sorry, gamma nu plus m plus 1. Now I can draw a special case whenever nu is an integer. Okay, if nu is equal to n, means n is a positive integer. So it is a special case. Nu, normally nu, it is a positive real number, maybe 0. But if that nu is an integer, positive integer, in that case, j nu x, that can be written as j n x. Okay, because nu is equal to n. So what will be the Bessel function? J n x m0 to infinity minus 1 to the power m x to the power 2m plus n divided by 2m to the power 2m plus n m factorial. And this gamma notation I can write it as factorial notation, right? Means gamma of n plus m plus 1, then I can write n plus m factorial, n plus m factorial. So do you get it or not?
Yes, sir.
So it is a
Yes,
special
sir.
case actually. Now see, देखो that jnx, lastly I told jnx, it is x to the power n summation. You can write x to the power n outside, or you can multiply it inside the summation. So I have multiplied that x to the power n inside. So it will be minus 1 to the power m x to the power 2m plus n divided by 2 to the power 2m plus n m factorial n plus m factorial. Here I have taken n as positive integer, and whenever n is a positive integer, that jnx, it is called Bessel function of first kind of order n. Okay, and general form, it is this j nu x. So j nu x, you see the difference is here. It is gamma m plus nu plus 1. Other places same. In place of n, I have written mu. Sorry, nu. So it is called a Bessel function of first kind of order nu. Okay. Now look, I have not made any conclusion about the second solution. Means that j n x or j nu x, these are corresponding to what? Corresponding to the first solution, right? Means y1, after modifying y1, we got this Bessel function. So there should have second solution also na, for this OD, for r is equal to minus nu, for r is equal to minus nu, right? So I'm not discussing about this. I will tell you this about the second solution, means about the uh, other solution later. That is another type, another kind of result also, I will tell you. Okay, now we have four properties of this Bessel function. Proof of these properties are important. Sometimes in exam it may come. These four properties. Okay, so these are related to actually derivative of Bessel functions. So see how they are related. So it is saying that, look, sometimes you will get direct proof of these properties, some of these properties, or some application of these properties. Now see, first property, it is saying that the derivative of x to the power nu j nu x means we have the series for j nu x, right? So it is the form of j nu x. Now it is saying that if you multiply j nu x by x to the power nu, and then if you differentiate it with respect to x, so it is x to the power nu j nu x whole derivative. Okay, so it will give x to the power nu j nu minus 1. Fine. X to the power nu j nu minus 1. So here the derivative of j nu is related to j nu minus 1. Similarly, if we multiply j nu by x to the power minus nu, previously we have multiplied x to the power nu. Next property says that if we multiply j nu by x to the power minus nu, and then if we differentiate it with respect to x, it will give minus x to the power minus nu j nu plus 1. Okay, third result says that the addition of j nu minus 1 and j nu plus 1, it is equals to 2 nu divided by x j nu x. So it is a relation between three consecutive Bessel function, right? It is a Bessel function of degree nu. It is a Bessel function of degree nu minus 1. It is nu plus 1. So nu minus 1, nu plus 1. So it is a relation between three consecutive Bessel's function. And another property, it is about the difference of j nu minus 1 and j nu plus 1. Property number 3, j nu minus 1 plus j nu plus 1. And property number 4, j nu minus 1 minus j nu plus 1. So it will be 2 into j nu dash x. So how to prove it? We'll see. Now see, proof of this actually proof of this property is very easier. It is all about adjustment, means summation calculation. So how to prove it? You see. The first property I am writing, it is x to the power nu j nu x derivative of x to the power nu j nu x is equals to x to the power nu j nu minus 1 x. Okay, so proof. See, what is the series for j nu x? First you write it. J nu x. We know that j nu x. What is the series? Minus 1 to the power m x to the power 2m plus n, not n, 2m plus mu divided by 2 to the power 2m plus nu m factorial gamma of m plus nu plus 1. Now you multiply it by x to the power nu. So x to the power nu j nu x. It will be what? M 0 to infinity minus 1 to the power m x to the power 2m plus 2 nu, right? Are you getting how I am writing x to the power 2m plus 2 nu? Previously it was 2m plus nu. Now I am multiplying it with x to the power nu. So x to the power 2m plus 2 nu into x to the power nu. क्या हो जाएगा? It will come, right?
Yes, sir.
Divided by 2 to the power 2m plus nu m factorial gamma of m plus nu plus 1. Now we have to differentiate it, right? So differentiating this with respect to x. So it will be left hand side will be d dx of x to the power nu j nu x, which is equals to now I am differentiating right hand side. So it will be what? All except x to the power 2m plus 2 nu, all other means terms are constant. Na? So only we will differentiate this x to the power 2m plus 2 nu. So summation m 0 to infinity minus 1 to the power m 2m plus 2 nu x to the power 2 nu minus 1 divided by 2 to the power 2m plus nu m factorial gamma gamma what? M plus nu plus 1. Now you have to think a bit. We have to get the summation form in j nu minus 1 x form. So what is the form of j nu minus 1? What is the summation form of j nu minus 1? That you think. So summation form of j nu minus 1 means in place of nu, you think nu minus 1. Okay. So it will be x to the power 2m plus nu minus 1. Then in the denominator 2 to the power 2m plus nu minus 1. Then m factorial. Then gamma of, in place of nu, if you put nu minus 1, it will be what? Gamma of m plus nu, right?
Yes, sir.
So is this coming? For that, देखो अब थोड़ा सा you need some you need a bit simplification. No other things are required, just simplification. So 2m plus 2 new, I am writing it 2 into m plus new. Okay, now x to the power 2m plus 2 new minus 1, I am writing it as x to the power 2m plus new minus 1 into x to the power new. Can I write this? Divided by 2 to the power 2m plus new, then m factorial, then gamma of alpha plus 1, that can be written as alpha gamma alpha, right? By the property of gamma of alpha plus 1, it is equals to alpha gamma alpha. So can I write gamma of m plus new plus 1 is equal to m plus new gamma m plus new? Can I write this? By applying the property, again I am writing gamma alpha plus 1 alpha gamma alpha. Here alpha is equal to actually m plus new. Now see, this cancelled out, and if you move that 2 in the numerator, okay, to the denominator, to this 2 to the power, then it will be what? 2 to the power 2m plus new minus 1. Can I write this? And I am also bringing that x to the power new outside the summation because it is independent of m. So I can bring it to the outside of this summation. So m 0 to infinity minus 1 to the power m x to the power 2m plus new minus 1 divided by 2 to the power 2m plus new minus 1 m factorial gamma of m plus new. Now is not it j new minus 1? That summation form. Only see the summation form. Is not it j new minus 1?
Yes, sir.
Yes. Now tell me if you have any kind of doubt here. See and tell me. Any doubt?
हेलो हेलो।
Ah, yes.
सर आपकी आवाज नहीं आ रही थी।
No, I have given you time for checking.
नो डाउट सर।
यस सर करेक्ट चेक करना चाहिए.
Okay, so um, proof of the first property is over. Now second property. It is x to the power minus new j new x. Its differentiation, it is equals to minus x to the power minus new j new plus 1x. Okay. It is also very simple. Just you need to take one substitution here. Uh, okay. So property number 2. It is d dx of x to the power minus new j nu x, which is equals to minus x to the power minus nu j nu plus 1 x, right? Let me check whether I have written the property correctly or not. X to the power minus nu j nu, it is equals to minus x to the power minus nu j nu plus 1. Okay. Now same thing you do, you just write the summation form of j nu, then you multiply it by x to the power minus nu, then you differentiate it with respect to x. Okay, j nu x, it is what? Minus 1 to the power m x to the power 2m plus nu divided by 2 to the power 2m plus nu m factorial uh, gamma of m plus nu plus 1. Now x to the power minus nu multiply j nu by it. Then it will be minus 1 to the power m x to the power what? 2m. Isn't it? X to the power 2m plus nu into x to the power minus nu. So it is x to the power 2m. 2 to the power 2m plus nu m factorial gamma m plus nu plus 1. Now differentiating with respect to x, d dx of x to the power minus nu j nu x. Tell me after differentiation what I will write. This, isn't it?
Yes, sir.
Now what are the limits? 0 to infinity? Think. 0 to infinity or something else? Tell me. Already I have shown various type of differentiation on summation. Tell me in the okay. You tell me in that x to the power minus nu j nu x summation. X to the power minus nu j nu summation. What is the first term? By putting x is equal to 0, sorry, m is equal to 0, the term is constant term, right?
Yes, sir.
Yes. Now if you differentiate it, that first term, it will be 0.
Yes, sir.
So 0 means first term is vanishing after differentiation. Now what will be the limit then? 1.
The one
One.
to infinity.
1 to infinity. Okay. Now adjust the terms to get j nu plus 1. Now j nu plus 1. For that you first think that what is the series for j nu plus 1. I have already written here j nu. So what is the series for j nu plus 1? Minus 1 to the power m x to the power 2m plus nu plus 1 2 to the power 2m plus nu plus 1 m factorial gamma m plus nu plus 2, right? It is a series for j nu plus 1. So how to get it? And before that, see, to get to get the form of Bessel function, you have to convert lower limit to 0, isn't it, right? So first of all, you convert lower limit to 0. How to convert that lower limit to 0? If I take, means here m is equal to 1, means m minus 1 is equal to 0, right?
Yes, sir.
So if I take m minus 1 equals to s, I am taking m minus 1 is equal to s, then lower limit will be s0 to infinity, right?
Yes, sir.
So you should understand that what is the need of this substitution. Okay, s0 to infinity. Now m means what? M means s plus 1. So minus 1 to the power s plus 1 and 2 into m means s plus 1 x to the power 2s plus 2 minus 1, 2s plus 1, 2 to the power m means s plus 1. So 2 to the power 2s plus 2 plus nu, this, this, and this. Any doubt?
No, sir.
No, sir.
Now again, you think the form of j nu plus 1. Look, to be in the form of j nu plus 1, it will be x to the power 2m plus nu plus 1, right? So it is only 2s plus 1. Better, if you are confused with this notation, you again change to m. Okay, you can change that s to m na, because s is the dummy variable. In the variable s, it may be unclear to you. So better you change to m again. So I am changing m again. M 0 to infinity and minus 1 to the power m plus 1, then 2 into m plus 1. Am I connected? Okay, who is Asutosh Bera? Fine. Minus 1 to the power m plus 1, 2 into m plus 1, then x to the power 2m plus 1 divided by 2 to the power 2m plus nu plus 2, m plus 1 factorial and gamma of s plus nu plus means m plus nu plus 2. Now we are very close to actually j nu plus 1. See, m 0 to infinity, can I write minus 1 to the power m plus 1 is equal to minus 1 to the power m into minus 1. So I can write minus into minus 1 to the power m. Can I write this? Minus 1 to the power m plus 1. Minus 1 to
Yes.
the power m into minus 1 to the power 1. And minus 1 to the power 1 means minus 1. So this. And see, uh, that m plus 1 and m plus 1 factorial made some elimination. It will be what? m m factorial, right? M plus 1 and this m plus 1 factorial. M plus 1 factorial means m plus 1 into m factorial. So m plus 1 cancel out. It is m factorial. And these two in the numerator, I am moving it to the numerator, sorry, denominator. So it will be 2 to the power 2m plus nu plus 1.
Yes, sir.
And it is x to the power 2m plus 1 and gamma of m plus nu plus 2. Is it clear to you or not? That last form, how I am getting the last form from the previous one. Anywhere?
सर माइनस कहाँ से है?
Mm-hmm.
सर माइनस कहाँ से है?
Look, minus 1 to the power m, that can be written as, sorry, m plus 1.
Yes, yes, sir. Yes.
I can write this. Okay. Now, is it exactly j nu plus 1? So in the form of j nu plus 1, it should be x to the power 2m plus nu plus 1, right? 2m plus nu plus 1. So it is only x to the power 2m plus 1. So what I can do, I can multiply it with x to the power nu, and then again to neutralize it, I can multiply it with x to the power minus nu. Now that x to the power minus nu, I am moving it outside the summation. So it is minus x to the power minus nu m 0 to infinity minus 1 to the power m x to the power 2m plus 1. Sorry, now I can multiply these two, x to the power 2m plus 1 and x to the power nu. Now in the summation format, is not it j nu plus 1?
Yes, sir.
Any doubt? Tell me. Look, compared to the first property, Second property is a bit difficult because here you have to take this substitution m minus 1 is equal to s, and then you have to adjust to the form of j nu plus 1, right? Done. Now actually third and fourth, these are some kind of applications of the property number 1 and 2. You see, now property number 3, j nu minus 1x plus j nu plus 1x is equal to 2 nu divided by x, j nu x. Now see how I'm doing the proof of 3 and 4. So what is happening? Okay, now देखो d dx, the left hand side, it is d dx of x to the power nu j nu x. Now if you explain means expand it, the differentiation of this, then what I can write? You just apply the d dx on this. What I can write? Multiplication rule you apply. So it will be x to the power nu into j nu dash x plus nu x to the power nu minus 1 j nu x. If I apply d dx on this, then d dx of this equals to this, right? Do you get it?
Yes, sir.
Now this I can write this equals to this. Means left hand side we can substitute by x to the power nu j nu dash plus nu x to the power nu minus 1 j nu x. Similarly, for the second, you apply the derivative. Okay, you will get this type of term. Similarly, for the second, so I am showing now. So applying derivative on first, I am getting this, and applying the derivative on second, I am getting this. Now what I did, I have subtracted first from second, not first from you can do it, but exactly I have done subtracted first from second. Here, yes, double star minus single star. Yes, so these two terms will be eliminated, and the rest you see, you will get the ultimate relation. Okay, you see this in my from my note in the next class. Otherwise, I will discuss. Actually, there are some celebration going outside. I think it is for both. So that's all for today. Okay, I'm not extending further.
Sir, attendance.
I will give all present.
Thank you, sir.
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 Thank you,
Thank
sir.
you, sir.
Thank you,
Thank you,
sir.
sir.
Okay,
Thank you,
thank
sir.
you.
Thank you, sir. Thank you.